So this is a solved problem on Newton's law and forces. The first problem that we had is, I called it Pulley problem 1. So we had two blocks, block A and block B. Block A is placed on a horizontal frictionless surface. So we have a frictionless surface here, and it's connected by a wire to block B. Block B hangs vertical. So block B is vertical. The other thing we know is that the cord and the pulley both are massless, and the pulley is frictionless. So we don't have to worry on what's happening on the pulley. What we want to find is the acceleration of block A. And in this, both ways, we're going to find the acceleration of block B as well. And also the tension in the cord. So whenever we have a question about acceleration, the first thing we think about is Newton's law. So we have to apply Newton's law to find the acceleration. So that's our strategy. But the thing is that block A and block B are going to move together. So when we think about it, we cannot study block A alone or block B alone. We have to study them together. So we have two objects that we want to study. We want to study block A and block B. Then we start by forces. So this is the first step. We know the objects that we are studying. And our second step here, knowing the forces on the objects. Then we have, what are the forces on A? We have the weight of A. We have the tension in the cord. Tension always along the direction of the cord. And we have the normal reaction, which is perpendicular to the surface. For B, we don't have normal reaction for B. We only have weight, which is vertical down, and tension, which is along the surface. We called those forces here WA and TA. Here we don't need to call it NA because we only have one normal reaction. Then we choose axes. So the first axis I'm going to choose for A is the x-axis. Why? Because if A is going to move, it's going to move along the table. So it's going to be the direction of motion. When I have the x-axis, it's not enough though. Why? لأنه الN والweight are not on the x-axis. So I have to have another axis, so I choose the y-axis. I only need two because that's the only two directions. For B, I enough have one axis because the forces are in one direction. I don't need, there's no need for the axis to be common between A and B. And when I write the equations, I'm going to write the equations of A alone and the equations of B alone. So I have no obligation إنه يكونوا هاي Y وهاي Y. في أخذ axis هيك sideways. But I'm not going to do that here because, well, the block is going to move up and down, so it doesn't make sense to take sideways. Okay, so I start by writing Newton's law for block A. So I have WA vector plus N vector plus TA vector equal to MA times the acceleration of A. Then I project on the y-axis. On the y-axis, there is no projection for TA. I got plus N and minus MAG. The acceleration on Y, I know is 0. The acceleration of A is not 0. The block A is, I want to find this acceleration, but I kind of know that it's not going to move up and down. It's going to move along the surface. So I know that the acceleration or the Y component of the acceleration of A is 0. So this actually doesn't give me any information or new information. I already know AY. So I need to do the projection on the y-axis. On the y-axis, I have only one force, so it's plus TA. So this force is in the positive x direction, equal to the mass of A times the acceleration of A in the x direction. So this is my unknown. The acceleration in the x direction is what I want to find. But I cannot find it from here because I don't know TA yet. So I do the Newton's law for B. Newton's law for B tells me that WVB vector plus TB equal to MBAB vector. I have one axis, so I project on the y-axis. I got minus MBG plus TB equal to MBABY. Again, ABY is also unknown. So, from Newton's law, I got two equations. This is the first equation from Newton's law of A, and this is the second equation from Newton's law of B. But in these two equations, I have four unknowns. First, the accelerations that I mentioned, but also the tensions are unknown. So I have two missing equations to be able to solve it. Before we find the other equations, let's actually rearrange this equation. So I'm going to keep TB on the left-hand side and move this to the right-hand side. So it's equal to MBG plus MBABY. Now, what I remember is that these two blocks are going to move together. And they're going to move together in a very specific way. If A moves in the positive x-axis, B is going to move in the negative y-axis, and vice versa. حتى لو I pulled A to the side, it's going to move this way, B is going to move the other way. So the acceleration of A on the x direction is equal to minus the acceleration of B in the y direction. Okay? So this is my third equation. I still need one more equation. And that I got from the tensions. As long as the cord and the pulley are massless, then the tension on one side has to be equal in magnitude to the tension on the other side. Because that means that I don't care about anything that happens in the middle. So what the wire does is propagate the force from one direction to the other. So TA in magnitude is equal to TB in magnitude. Right. I can start from here and replace TA and TB by the equations that I found from Newton's law. So I have MA multiplied by the acceleration of A on the x is equal to MBG plus MB, the acceleration of B on the y-axis. Again, MBY is equal to minus MAX, so I can replace that here. Then I can rearrange this equation, so I can take A, so here I have only one unknown, so I can rearrange this equation. I can take this to the other side. So I got MA plus MB multiplied by AX is equal to MBG. So I can find the acceleration as MBG over MA plus MB. So let's see if this makes sense to us. So in the numerator, we have the weight of B. So the weight of B is pulling B down on the y-axis, but it's pulling A forward on the x-axis. The wire, all the wire does is transfer this force from B to A. Now, divided on it, we have in the denominator, we have the mass of A and the mass of B, which is the total inertia. Because the masses are moving together, I have to divide by the total inertia. Of course, now tensions are not going to show up in this final equation because now they are internal forces in the whole system. Will weight of A, when we did the projection on the y-axis, it cancelled out with the normal reaction. So that makes sense. And of course, we already know that the acceleration on the y direction is 0. So we have the full acceleration. Finally, we need to find the tensions, TA and TB. TA is equal to TB. And I can just replace in this equation here, right? So it's equal to MA MBG over MA plus MB. I can check the dimensions. This is mass square over mass is mass times acceleration. So that's the unit of a force. And the job of the tension is to transfer the force from one object to the other. Okay, thank you.